Here we have a cubic function, and we can see that we can drag the point along the curve, and it's just showing us the function value, the x value and the y value. Remember the function value being the y value. Now we're showing the gradient at this point, and the gradient tells us about the behavior of the function. Since the gradient is negative, we know that the function is decreasing, and you can see all along this curve at this stage, the function is decreasing as we move along, always from left to right, negative gradient. At this point over here, the gradient is 0, and the function turns. Thereafter, the function starts to increase, and we have a positive gradient. At the next turning point, the gradient will again be 0, and then the gradient goes negative again. Now we're plotting the tangent to the curve, and we can see, not surprisingly, that the gradient of the tangent is exactly the same as the gradient, the instantaneous gradient of the curve. What we're going to do now is we're going to plot the gradient of the function as we move along. So the orange dot in the bottom left-hand corner of the screen is representing the gradient. You can see the y value, the y coordinate of that point, is the same as the gradient. Right, so what we'll see, right, is that it traces along, and we can see a couple of things. Firstly, that the gradient is negative. That point is below the axis. However, the gradient is increasing. It's becoming kind of less negative as we move along. Right, it's in fact getting closer and closer to 0. Remember that when the function turns at the turn point, it has a gradient of 0. So I'm just going to try and go slowly through here, otherwise we get a few holes in the function. There aren't actually any holes. Right, notice at the turning point, when the gradient is 0, we are on the x-axis, because the y value of this orange point is representing the gradient of the black curve. Right, and as we move along, we can see the gradient still increasing. Somewhere over here, the gradient actually maxes out and starts to decrease. Right, and it's decreasing now. It's still a positive gradient, but decreasing. Right, at the next turning point, the orange point will be back on the x-axis because the gradient is 0. Right, and now the gradient goes negative, and notice the gradient is still decreasing. Right, the derivative of a cubic expression is a quadratic expression, which is why we've ended up with a parabola. We're now showing the second derivative. The second derivative tells us about the behavior of the first derivative. If the second derivative is positive, as it is at the moment, it means that the first derivative, the gradient, is increasing, and we can see that. So notice that the second derivative is positive all the way along here until this point over here, where the gradient starts to decrease. And when the gradient starts to decrease, the second derivative is negative. We're now going to plot the second derivative. All right, and remember that it's showing us the gradient of the orange line. Now, the orange line initially has a positive gradient, then a gradient of 0, and then a negative gradient. The second derivative will actually be in the shape of a straight line, because the derivative of an x squared function, a quadratic function, is a linear function. And we can see that, in fact, the second derivative is being plotted as we move along here. Notice that the second derivative is positive above the axis all the while, right, because the gradient is still increasing. Okay, at this point somewhere over here, the gradient stops increasing and starts to decrease. And notice the second derivative now becomes negative. We're now going to show the point of inflection. The point of inflection is the point at which the gradient goes from increasing to decreasing, or vice versa. Right, it's the point at which the second derivative changes sign. Let's have a look. So notice the gradient is increasing and the second derivative is positive. After that point, the gradient starts to decrease and the second derivative becomes negative. Just going to go through that point again, and we can see how the tangent line sort of kicks over. Right? It's sloping uphill, 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 further and further uphill, and then it starts to actually tilt downhill. This point is called the point of inflection, and it's the point at which the concavity of the curve changes. All along this piece of curve, the function is concave up, shaped like a cup. The gradient is increasing, and the second derivative is therefore positive. Once we go past the point of inflection, the gradient starts to decrease, the second derivative is negative, and the curve is concave down, like a frown. So this piece of curve here, concave up, like a cup. And this piece of curve here, concave down, like a frown. We hope you found this video useful. If you did, please subscribe, like, and share. Thanks and have a great day.